So let's go through the steps of how to prove something by mathematical induction. So step 1, we have to prove or show true for the first term. So does the first term equal to the first term given with that formula? Meaning, when does n equal to 1? And of course that is true. The second step is our assumption statement, so we want to assume true for n equals to some kth term. So what we're basically doing is we're writing down the problem just as is, but replacing n with k. Those are the easy steps. The third step is we have to prove true for the next term. So we're actually going to add something here, and we're going to change those to k plus 1, meaning is it true for the next term. So we have 1 plus 2 plus 3 plus 4, exactly like it is. Then we're going to add that next term, and the next term comes from whatever that was, replace it with k plus 1. Want to show that is true. So we look at this and we go, hey, I already know what that equals to. We assumed it to be equal to that. So I can replace this statement with what it's equal to, which is k over 2 times k plus 1. And now I'm adding the next term. And I want to see, does it equal to k plus 1 over 2 times k plus 2? All right, 1 plus 1 is 2. So on the left-hand side, I could factor it, I could distribute, but I'm going to kind of think about factoring since I have those as like terms. When you're factoring, what you're really doing is you're dividing each of your terms by my common factor. So, and then dividing it out and saying, well, what do I have left? I have k plus 2 plus 1. If I divide k plus 1 into k plus 1, it goes in there one time. And I'm going, well, does that really look the same? Not exactly. Okay, so let's kind of play with this a little bit. Let's factor out the 1/2. I know that looks weird, but okay, so 1/2 times k gives me k over 2. Now what can I multiply times 1/2 to get 1? 2. Convince yourself. 1/2 times 2, that equals to 1. And sure enough, that equals to what we want it to be. It's not as pretty, it's not in the same order, but it's the same thing. Just writing the 1/2 out in front as opposed to underneath k plus 1. And you're done. So again, let's go through the steps. We want to show or prove true for the first term. So does this first term equal to this when we replace n with 1? Oops, not 1/4 but 4. And yes, 4 equals to 4. So then we assume true for n equal to k, our assumption statement. So 4 plus 9 plus 14 plus 19 plus 5k minus 1, does it equal to this? Not does it, it does. We're assuming that to be true. Now we have to prove or show true for the next term. So again, we're taking this, we're writing it just like it is. And then everywhere there is a k, I am going to put in a k plus 1 in parentheses. So you have to do the whole thing. So I have to have the 5, and in place of the k, I have k plus 1. Don't forget that minus 1. And on this side, we're saying, does it equal to, again, everywhere there is a k, I'm putting in a k plus 1. So this is from my assumption statement. I know that is equal to this. I'm distributing my 5. I'll clean that up in a minute. Over here I have, does it equal to 5k plus 5 plus 3, which would be plus 8. That's what I want to know, does that work? So let me clean this left-hand side up just a bit, collecting like terms. The left side doesn't look anything like the right side. I can't factor anything, or at least I don't see anything I can factor. So I think I'll go ahead and distribute. And yes, I wrote that really strangely, so let me write it a little bit better. And since these are over 2, I need to find a common denominator and make those over 2 as well. So I have to multiply each of the numerators times 2. Then I'm looking over here and going, well, I need to factor out that 1/2. All of these now have a 1/2 in common, so I can factor out the 1/2. Collecting like terms. Okay. Again, trying to match this, which I almost have. I have the 1/2. Now at this point, depends on how good you are at factoring. You should be able to factor that, but you can look up here and say, hey, if I multiply this out, will I get this? Yes, I will. So I know that this factors into exactly what I need, and I'm done. You should try number 3. Go through the steps. So pause the video and then come back. Okay, so hopefully you have now given it a try. You have the steps written out. You can't just write the math, you have to write the words as well. So we're going to show true for n equals to 1. Then we have our assumption statement here, and then we have to get to work. So again, we use our assumption statement, saying what does all of this equal to? So we can say our assumption statement equals to this, so I can replace it. And then bring down the rest. I'm going to distribute the 3. And again, I want you to call your attention to, what did I do? I took this, which was here, then added the next term by replacing k with k plus 1 in parentheses. Same thing on this side. Everywhere was the k, I put in a k plus 1 in parentheses. So I'm going to distribute this, and I'm going to have 3k plus 3 minus 5 is a negative 2. So just like on the last example, I'm going to collect like terms. Then I'm going to distribute. I'm going to go ahead and find a common denominator of 2. I'm going to factor out my 1/2. I'm going to go ahead and collect like terms here. So that gives me a plus k and a minus 2. And at this point, I'm going to say, hey, does this factor into that? Multiply that out in your head on some scratch paper and say, hey, does that equal to what I need it to equal to? And yes, it does. So I need to factor this and be done. Now the next example, we have those exponents, which I know everyone struggles with. All right, so we're going to show true for n equals to 1. Does the first term equal to this? And yes, it does. Writing down our assumption statement. And now we have to get to work. Okay, so again, we write down exactly that, not changing a thing. And then we add the next term. So wherever there is a k, I'm going to replace it with k plus 1. Same thing on this side. Now y'all should know that k plus 1 minus 1 is just k. We'll do that on the next step. Okay, so using our assumption statement, knowing that our assumption statement can be replaced with that, I have 1/2 3 to the k minus 1 plus 3. What did that all equal to? Just k. So now I'm looking over here, looking what I have, and going, kind of matches, but not exactly. So I'm going to distribute. So that's 1/2 times 3k minus 1/2 plus 3k. These are like terms, so I can keep what is alike, and remember, add the coefficients, adding the coefficients. So 1 plus 1/2 is 3/2, and I'm bring down the negative 1/2 that I have from here. So I'm looking at what I need, so I'm going to factor out the 1/2. So I have 3 times 3 to the k minus 1. That's looking pretty good. And then I know those are the same bases being multiplied. I can keep the base and add the exponents, and that's exactly what I needed to prove. Hope this helps.